welcome to the strategy session. I'm your host, and today we are treating your Cambridge mathematics exams exactly like a MasterChef kitchen. Think about it. A top-tier chef doesn't just throw raw ingredients onto a plate. They have a recipe for success. They need the right ingredients, which is your evidence. They need precise cooking techniques, which is your analysis, and they need beautiful plating, which is your final evaluation. Today, our primary ingredients are straight-line graphs. We are going to take this abstract algebra and transform it into the ultimate exam weapon for syllabus codes like 0580, 0606, 4024, 4037, and 4040. If you've ever stared at a past paper and felt your mind go completely blank, you are in the right place. We're going to bridge the gap between knowing the math and actually scoring the marks.
Look at this incredible bungee jumping image. In the real world, straight-line graphs aren't just for dusty textbooks. They literally save lives in high-stakes experiments like load-testing bungee ropes. But let's bring this back to the exam room. Let me introduce you to two students we see all the time. First, there's Alex. Alex looks at a question like this and completely overloads the page with raw mathematical facts, dumping every formula he knows but providing zero actual analysis. Then we have Sam. Sam rushes. She sees a graph, panics, and totally misses the command word requirements in the question prompt. Look at this mental split screen. Alex's paper is covered in red ink because he didn't link his math to the reality of the rope. And Sam lost 3 marks just because she didn't read the word hence. Today, we are going to fix both of those fatal errors and show you exactly how to secure every single mark.
All right, here is our roadmap to mastering this topic. First, we'll quickly run through the straight line basics. Then, we'll level up to parallel and perpendicular lines. Third, we'll dive into taming nonlinear data. And finally, modeling real-world scenarios.
Let's kick things off with Section 1, the straight line basics. This is where we prep our core ingredients.
Okay, so here is the foundational rule, the absolute bedrock of coordinate geometry. Y equals mx plus c. Now you already know that m dictates the gradient, the slope of the line, and c anchors it perfectly to the y-axis. But from a Cambridge exam strategy perspective, simply knowing this isn't enough. When the command word asks you to state or find the equation, examiners are looking for you to explicitly define these two components. This is where we start using our PEEL framework. Point, evidence, explanation, link. Your point is identifying that you need a linear model. Your evidence is extracting m and c from the data given. If Alex just wrote y equals mx plus c without substituting the correct values from the bungee jump data, he gets absolutely nothing. You have to actively use the recipe.
Now, what happens if the examiners decide to be tricky and they hide the y-intercept from you? This happens all the time in 0606 papers. If you only have the gradient m and a single random coordinate on that line, let's call it x1 and y1, this alternative formula is an absolute lifesaver. It's y minus y1 equals m times x minus x1. Sam used to waste precious minutes trying to calculate c first, making silly arithmetic errors along the way. But by jumping straight to this formula, you instantly construct the equation. It's a massive time saver. It streamlines your working, which means less red pen from the examiner and more green check marks for you.
Let's look at the core properties of a line segment. Finding the midpoint is literally just taking the average of the x-coordinates and the average of the y-coordinates. And the length? That is just Pythagoras' theorem wearing a clever disguise. But listen closely, because this is where exam technique is crucial. If a question commands you to calculate the exact length, and you give a rounded decimal, you drop a mark. Exact means you leave it in surd form, right under that square root. This is the explanation and link part of our PEEL framework. You do the math, but then you must link it back exactly to what the command word demanded.
Moving right along, let's step into Section 2, parallel and perpendicular lines. This is where multiple ingredients start interacting in our exam kitchen.
Here we clearly see the difference between two fundamental relationships. Parallel lines run alongside each other endlessly, so their gradients are identical. Gradient 1 equals gradient 2. But perpendicular lines, they clash aggressively at exactly 90 degrees, meaning their gradients are negative reciprocals. Multiply them together and you always get -1. Now, before we look at a massive exam challenge using this rule, I want to make sure you are getting all these insider tips. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Seriously, do it, because mastering these small analytical tricks is what pushes you from a B to an A star.
Okay, here is the transformation I promised you. Finding a perpendicular bisector is a classic high-mark exam question that used to terrify both Alex and Sam. Alex would write a wall of numbers with no structure, and Sam would do the steps out of order. But look at this success blueprint. We break it down into 4 logical steps. Step 1, find the midpoint. Step 2, calculate the original gradient. Step 3, find the perpendicular gradient using that negative reciprocal trick. Step 4, substitute the midpoint and the new gradient into your straight line equation. If you structure your answer exactly like this, the examiner's red pen transforms into green check marks. You are literally showing them the Peel framework in action. Point, evidence, explanation, link. It goes from an intimidating 5-mark question to a guaranteed perfect score.
Now we are entering the really high-level stuff. Section 3, Taming Nonlinear Data. This is where the top-tier candidates separate themselves from the pack.
Stop scrolling! Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's look at this absolutely brilliant quote from our source material. In reality, data curves, bacterial growth, radioactive decay, they are non-linear. But Cambridge examiners want to see if you can take a complex, curved, exponential relationship and tame it into a straight line that we can easily analyze. How do we do it? We use the mathematical magic trick of logarithms. If you can master this conversion, you unlock access to the hardest questions on the entire syllabus.
Pay close attention here because this is our interactive workshop segment. Notice how taking the log of both sides forces these complex curves into our simple y equals mx plus c template. On the left, the power model transforms so that log y is our vertical axis, n is our gradient, and log a is our intercept. On the right, the exponential model uses natural logs, or ln, to do the exact same thing. In a moment, I'm going to put 60 seconds on the clock and challenge you to extract data from a table using these exact transformations. Are you ready to test your command word decoding? Let's go.
Let's bring this all together in Section 4, Modeling Real-World Scenarios. Time to apply our exam strategy to actual data.
All right, challenge 1, data scan. I'm virtually putting 60 seconds on the clock. Look at this data table tracking mass over time. If you plot t against y, it curves. But look at the bottom 2 rows. The raw data has been converted into log t and log y. Challenge 2, find the flaw. Imagine Alex wrote a paragraph saying, the gradient is calculated by dividing the change in mass, y, by the change in time, t. Did you spot the flaw? He completely ignored the logarithms. He loses all the marks. The correct exam technique, the correct Peel application, is to explicitly state that the gradient must be calculated using the change in log y divided by the change in log t. That is how you prove your evidence. Okay, challenge 3, speed writing. You have 30 seconds to mentally write a perfect paragraph decoding this graph. How do you find n and a? Time's up. Here is the examiner commentary on the perfect answer. You state that the gradient of the straight line gives you the value of the power n. That's your first mark. Then you state that the vertical intercept gives you the value of log a. To find a itself, you must use the inverse log, 10 to the power of the intercept. Sam used to just leave her answer as log a and lose the final accuracy mark. Don't be like Sam, follow it all the way through.
This works for exponential decay too, like Seb's cooling coffee. The temperature drops rapidly and then slows down. By plotting the natural logarithm of the temperature against time, the curve flattens into a perfect straight line. When you see a real-world scenario like this on your paper, your time management matrix should instantly trigger. You shouldn't be wasting 5 minutes wondering what to do. You instantly know. Exponential decay means I take natural logs, plot the straight line, find the gradient for the rate, and find the intercept for the initial temperature. Boom! Full marks in half the time.
And it doesn't matter how weird the equation looks. If you have y squared equals a times x cubed plus b, don't panic. Just plot y squared on the vertical and x cubed on the horizontal. The gradient is a, the intercept is b. So, here is our complete mathematics success blueprint, our 3 rules that guarantee top marks. Rule 1, command word decoding. Always know exactly what the verb in the question is asking you to do. Rule 2, Peel framework application. State your math, show the substitution, explain the calculation, and link it back to the specific question. Rule 3, time management matrix. Use shortcuts like the alternative straight line formula to save time for the heavy lifting log questions.
Mathematics is all about finding the simple straight lines hiding inside complex curves. And acing your exams is about having the right strategy to reveal them. Students who implement these math strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing, keep decoding those command words, and I'll see you in the next explainer.